The first question was the modulus of x plus 1 over x plus 3 less or equal to 3. The first step here is you have -3 less or equal to x plus 1 over x plus 3 less or equal to 3. Meaning, the first piece is -3 less or equal to x plus 1 over x plus 3. And the second piece is x plus 1 over x plus 3 less or equal to 3. So we solve each piece and then intersect the solutions. So this is -3 minus x plus 1 over x plus 3 less or equal to 0. Over 1 there, of course, so that we get x plus 3 and then -3 x plus 3 minus x plus 1 less or equal to 0, giving us -3x minus 9 minus x minus 1 over x plus 3 less or equal to 0, so that we get -4x.
Sir, you're too fast.
No, here I'm just doing the calculations, Kaidi.
Yes, sir, even though.
Okay. Okay. Over the denominator x plus 3 less or equal to 0. Then we said that whenever you have a fraction, you look for the critical values. There's no cross multiplication. So you get the numerator, equate it to 0, obtain the value of x, which is -10, actually +10 over -4. Now this 10 will go this side as a positive number. Then you divide -4 and obtain x is equal to 2 can go in both. So you get 5 over -2. Then x plus 3 equated to 0 will give us x is equal to -3. Then from there, you form a table. So let me form a table from up here. This is -3, and this is -5 over 2. A number bigger than that is 0. A number less than -3 is -4. And then I'll get the numerator, which is -4x minus 10.
So
Hello.
the reason why we have -3 and +3, it's because of the modulus.
Yes.
All right, thank you.
So you form a table of that nature, and then -4x minus 10 divided by x plus 3. So we have this table here. We want to test. What's the middle number there? There's no whole number that is in between -3 and -5 over 2. So what we do is we'll add those two, plus -5 over 2. Get the common denominator, which is 2. That will be -6 minus 5, which is -11 over 2. Then divided by 2. So -11 over 2 divided by 2 will give us -11 over 4. Like that. Then now you test. So you get -4 and take in -4, -4 minus 10. This is 16 minus 10, positive. Then -4 plus 3, This is -1, negative. So positive divided by negative will get negative, meaning that there will be a positive here and a negative there. So we want where this guy is less than 0, less or equal to. So our solution set 1 is going to be from -infinity up to -3. -3 is coming from a denominator, so we cannot include it. But -5 over 2 is coming from the numerator, so we can include it because we have less or equal to. So first piece sorted out. We have second piece. So here you get x plus 1 over x plus 3 minus 3 over 1 is less or equal to 0. So you have x plus 3, and then you have x plus 1 minus 3, x plus 3 less or equal to 0. Then we have x plus 1 minus 3x minus 9 over x plus 3 is less or equal to 0. Simplified version is -2x minus 8 over x plus 3 less or equal to 0. Critical values also here. We have -2x minus 8 equated to 0, giving us x is equal to -4. Also x plus 3 equal to 0, giving us x is equal to -3. Testing table, we have -4, we have -3. A number bigger than -3 is 0, less than -4 is -5. In between, we'll add these two numbers, -4 minus 3, we get -7 and divide it by 2. This is our middle number. And then we'll have -2x minus 8, x plus 3, then -2x minus 8 over x plus 3. So we are forming a table of that nature. So we test. When x is -5, we will have -2, -5 minus 8. This is 10 minus 8, which is 2 positive. And this will be negative, so I have to get a negative here. So this will be positive, and this will be negative. So I'm trusting you now to be able to finish up the tables inside there. Are we able? Okay, silence is acceptable. So for the top one, 0, here to minus, and then plus, so you can see that it's minus. So the middle one, -2, -7 over 2. And -8, we'll get +14 over 2 minus 8. That will be negative. And then, because this is negative, this is +7 minus 8, which is negative. Then, -7 over 2 plus 3, that will be -7 plus 6 over 2, which is negative. So the product or the quotient there is going to be negative, positive. So we get that. So this was our solution set 1. Now we look for our solution set 2 coming from here. We want this guy to be less or equal to 0, meaning that we get the negatives, which is from -infinity all the way up to -4. -4 is coming from the numerator, so we include it, union -3 to +infinity. So to find the final solution set, we intersect solution set 1, intersection solution set 2. And I trust you when it comes to getting intersections of this kind of intervals, because we have dealt with them so many times. So that if you miss it, then I know it's just an error, but you had an idea. -infinity, -4, union -3, +infinity. So we start. Yes.
I'm behind on the solution for the first one, the solution set for the first one.
Okay. Daniel.
Yes, sir. I'm also behind, sir. How we usually get the solution set, if we can explain on that.
Okay. Let me work on that. When it is less or equal to, from the table, you want negatives. When it is greater or equal to, from the table, you want positives. You go for where there is positive. Being less or equal to 0 means negative. If I have a number line here, this is 0. 0 demarcates the positive from the negatives. So anything before 0, negative. So when we say less or equal to 0, we mean negative numbers. Greater or equal to 0, we mean positive numbers. So in this case, we had less or equal to 0. So from our table, we want to write the final solution. This division here is negative, meaning it's less than 0 in that region. Also negative, less than 0 in that region. So we get those intervals and make a solution set.
All right, thank you.
Then again, we have another less or equal to 0. So in this table, we want where it is negative. So notice that when it is less or equal, we always include the numerator numbers, because the numerator can be 0. It will give us 0 over something, which is 0, meaning the equal to part has worked. But we never allow the denominator to be 0, because if the denominator is 0, we'll have undefined thing. So we are saying no to undefined. That's why we don't include anything from the denominator, even if we have less or equal. That's why I've gotten solution set 2 is all the way from -infinity up to -4. You skip the positive interval and it start from -3 going to +infinity.
I understand now.
Okay. Then you now need to get the solution, the intersection, to form the whole solution set. So how do you get the intersection? We said between -infinity and that -infinity, we get the biggest. So it will just be -infinity. And between -3 and -4, we get the smallest. So it will be -4. Get it as it is. It's included, so you include it. Union, between -5/2 and -3, you get the biggest. So what is big here is -5/2. And then between infinite and infinite, it will just be infinite. This is our solution set.
Sir, repeat. Repeat, please.
All right. So when getting the intervals, the easiest way that we discovered is that if I'm having two numbers bounding this interval here, and so this interval here, the left number in that interval there, the left number here. Between negative infinite and negative infinite, we'll get the least, we'll get the biggest, but it's just negative infinite, so we get negative infinite. Between -3 and -4, we get the smallest. Now in negatives, the bigger numerical value is the smallest when you consider the negatives. So between -3 and -4, -4 is the smallest. Then you go to the next intervals, this one versus that -5/2. This is 2.5. Yeah, it's 2.5, which is when it is negative, is bigger than -3. So we get -5/2. Then between infinite and infinite, we get infinite. So this becomes our solution set. So this is the task which gave us headache. What was the other question? I don't think I recorded it anywhere near.
My English book has.
So you want the second question?
Yes.
It's 2 less than equal to x plus 4 over x minus 1 is less than
The
x
second question
plus
was
2.
2.
X plus 2, is it?
Yes.
Okay. This was the second question, right? So we are saying it's already in two pieces. Ours is just to separate 2 less or equal to x plus 4 over x minus 1 and x plus 4 over x minus 1 less than x plus 2. So we start with the first one. That will be 2 minus x plus 4 over x minus 1 less or equal to 0 over 1 there. Get the denominator, have 2x minus 1 less than x plus 4 less or equal to 0. So we have 2x minus 2 minus x minus 4 over x minus 1 less or equal to 0. 2x minus x, we get x. -2 minus 4, we get 6. And then x minus 1 less or equal to 0. Critical values, no cross multiplication. X minus 6 is equal to 0, implying that x is equal to 6. X minus 1 is equal to 0, implying that x is equal to 1. Table, 1 is the smallest, 6 the biggest. 2, 0 the other side. 7 here. X minus 6, x minus 1, x minus 6 over x minus 1. So we are testing here also. So when 0 is substituted where there's x there, here it will be negative, negative, positive. Then negative, positive, negative. Positive, positive, positive. The solution set, we want where it is less or equal to 0. Remember what we said? When less or equal to, you go for the negative. So we'll start from 1 up to 6. The numerator must be included, the denominator not included. First thing. So we are done with this interval here. We go to the other interval. X plus 4. So we are calling this solution set 1 over x minus 1 minus x plus 2 over 1 is less than 0. Get the common denominator x minus 1 and we'll get x plus 4 minus x minus 1 multiplied by x plus 2 less than 0. So that will be x plus 4 minus x squared plus 2x minus x minus 2 over x minus 1 less than 0.
Here, why is it that 1 is not included? In the
Because
solution set?
because it's in the denominator. If we include it, we'll have 1 minus 6 over 1 minus 1. This will give us negative 5 over 0. Is this less or equal to 0? It's undefined, is it?
Yes.
So that's why we avoid using 1. But if we use 6, it will be 6 minus 6 over 6 minus 1, which is 0 over 5, which is 0, which is equal to 0.
Yeah, okay.
Yes.
So, sir, just a minute over the same question she has asked. Something which is as a denominator, we don't have to include it.
Never.
Or what?
We should never include
Okay.
it.
All right. Thank you.
Even if they force you, you don't. Yes.
So only a question can only be undefined if the 0 is a denominator. So if it's a numerator, you can still go ahead.
If it's a numerator, you go ahead.
Okay.
Only when it's in the denominator. That's when it's undefined. So we'll have x plus 4 minus x squared minus 2x plus x plus 2 over x minus 1 less than 0. So x plus x, that is 2x, minus 2x, that is 0. So we remain with negative x squared plus 6 over x minus 1 is less than 0. Get critical values. X minus 1 is equal to 0, giving us x is equal to 1. Negative x squared plus 6 equal to 0. You only have to pick the numbers on the numerator and the denominator. So what I'm getting in your question is that do you only use these numbers to form the solution set? If that is your question, yes. You only use the critical values to form your solution set, not the numbers like 7, which you pick for yourself. I can pick 10. I would have picked 100. It's just a choice that you make. So it should not affect everyone's choice. Because if you use 7, then you mean that every person choosing must choose 7. Now, how do you reason in that way? All of you. So there'll be varieties. So from this one, we get that x squared is equal to 6, giving us x is equal to root 6, or x is equal to negative root 6. And then form a table, negative root 6, 1, and positive root 6. So we have a line demarcating here, another one demarcating there, another one demarcating there. Move like that, and then get negative x.
Excuse me.
Hello.
So just repeat on the part of negative x squared plus 6.
So negative x squared plus 6 is equal to 0. Take this guy the other side, you have negative x squared is equal to negative 6. Divide by negative 1, divide by negative 1. You get x squared is equal to 6. Then get the square root, get the square root to be x is equal to plus or minus root 6. So we separate them. You get x is root 6 or negative root 6. And then spread your numbers throughout the table. Oh, so I have to be a bit fast. We only have 8 minutes before it cuts. So negative x squared plus 6, and also x minus 1, and then the quotient. So I'll just say qx to mean the numerator over the denominator. Okay. So a number less than root 6, negative 10. In between, there will be 0. And here, there will be 2. Bigger 3. We know that root 4 is 2. So root 6 is bigger than 2. Root 9 is 3. So 3 is bigger than root 6. That's how it's easy to know what is happening there. When I have negative 10, negative 10 squared plus 6. Of course, this will be negative 100 plus 6, which is negative. Then we have negative 10 again, negative, giving us positive here. 0, this will be positive, minus, minus. 2, this will be positive, positive, positive. 3, this will be negative, positive, negative. So our solution set 2, is going to be where it is less than 0. When it is less than 0, you go for the negatives. That is negative root 6, comma 1, not including anything because you strictly have less than. And start from root 6 to positive infinity. So to form the whole solution, we get solution set 1 intersection solution set 2. That is from 1 to 6 intersection from negative 6 root 6 comma 1 union.
Sir,
Hello.
what's that number in that box is drawn? Now the last line there.
This one here.
There's yes.
That is just qx representing the fraction that we're supposed to write. We're supposed to write this whole thing.
Okay.
So the intersection, we are saying,
Yeah.
hello.
Sir, on this part for the critical values on the 3,
Yes.
we use all Okay, it's fine. I've seen where I've gone wrong.
Okay. Union root 6 up to infinity. So we get the intersection between -1 and negative roots, I mean between +1 and negative root 6. Which one is the biggest? So the biggest here would be 1. And then between 6 and 1, the smallest again is 1. So now there's nothing here. Union between root 6 and 1, the biggest is root 6. And between 6 and infinite, the smallest is 6. So our solution set, I mean, this 6 is included. So our solution set will be root 6 up to 6 included. This is our solution set. So when picking the solution set 2, how do you pick? Once you have the signs negative, negative, plus, plus, you check the final thing where you got the solutions from.
Can you explain how you did the intersection part? Like I tried looking at it and I'm not finding what you found.
Okay. So starting from solution set 2, you use the less, meaning it guides you to negative, negative, and then pick those intervals. Then getting the intersection. How do you get the intersection? You have from 1 to 6, 1 not included, 6 included. Intersection negative root 6 to 1. Between this interval here and this one, 1 and negative root 6, we said that you get the biggest. So the biggest between negative root 6 and 1 will be 1. Then between 6 and 1, you get the smallest. So the smallest is 1. Because both of them are open, it means that there's nothing in this interval. This is empty. Union between root 6 and +1, which one is the biggest? So the biggest here is root 6. So we have root 6 not included as it is there. Then between infinite and 6, which one is the smallest? The smallest is 6. So you get 6 as it is included there, so we include it. So now empty union this piece, we get this piece here as our solution. So this is what you are supposed to do in that task. So,
Sir,
hello,
I have a question.
please ask.
Why, what method are you using when getting the intersection and union? Where you're just saying that this one is smaller, this one is bigger?
The number line.
Or I have to draw the number line?
Yeah, you have to draw the number line or avoid it by just looking at those relationships.
And what's the relation, that relationship?
The same one you are saying, you look at the bigger number, because what it is that when you draw your lines, you always get where there are two lines. That is where the intersection. So now where there are two lines will only be those regions where -1, if they meet with that number, and also 6 if they meet with that number there. So now you notice that if the way 1 is bigger than -6, root 6, if you draw a line, you have -root 6, you also have 1 there. So you can't start from here because this line is going this side. This 2 is going this side. So you can't start from here. There's only one line. So you have to start from here.
Okay.
Where there are two lines. So that's how we use that relationship there.
Okay.
So it will be cutting. So I won't give you an exercise. So let's get back and do something else now. It's okay. No exercise. That'd be nice.